Yo, what's up, you nerds? Minitillo here, and let's get a couple more questions done in one video now that I know how to do this a little bit faster. Okay, so here we go. This is still the written response section on August 2015 Chemistry Regents, and here we go. So, looking at question 55, it says, given the formula for the compound heptanal, all right, and let me get a pen going here so I can start making some notes. So it says that we have heptanal. And here we have, actually, this is the structural formula. The structural formula is called that because it actually shows the structure or the shape in 2 dimensions of the molecule. So it's not just saying what atoms are there, what elements make up the molecule, it's actually showing the shape. So that's the structural formula. Okay. Now I see the question says, determine the gram formula mass of heptanol. But before we even mess with that, I want you to do something with me. So here's the structural formula. You can easily come up with the molecular formula by looking at how many atoms of each element there are in this molecule. So let's do carbon first. So I see 1, 2, 3, 4, 5, 6, 7. So I see 7 carbons. Okay, so C7. Let's do hydrogen next. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So that's C7H14, 14 hydrogens. And I only see 1 oxygen atom double bonded to the carbon atom there. There we go. That is the chemical formula for heptanol. Okay, now a couple things, even though these may not have to do with the question, just want to review a few things here. So look at the beginning of the name. You see how it says hept? Check this out. So if a molecule's name starts with the word, starts with a prefix, hept, if you look at table P, organic prefixes, this is for the naming of organic compounds. So an organic compound is any compound that contains carbon and hydrogen. So if if a compound contains the elements carbon and hydrogen, it is called an organic compound, because organic means living, and it turns out that living things, at least on Earth, are composed of carbon and hydrogen. So the name of the substance that they had in the question was called heptanal, and now check it out. If you look at table P, organic prefixes, it says hept means that there are 7 carbon atoms, which we saw is definitely the case in the formula. And now, why is it called heptanal? So again, now it's not going to be table P that helps us understand why it's called heptanal. But what we're going to do is go to table P, keep going. Table Q also has to do with organic compounds. We're going to come back to that later. But look at table R. Table R is also about organic compounds, but it focuses on organic functional groups. If you look right here, this is row 1, 2, 3, 4. If you look at row 4, these functional groups, these types of organic compounds are called aldehydes, and their names end in -anal. So for instance, this example they gave us right here is called propanol because it has 1, 2, 3 carbon atoms. So prop is the prefix for 3 carbon atoms. And if you look at what makes a substance an aldehyde, it's that you have a carbon atom double bonded, covalent bonds, by the way, a carbon atom double covalently bonded to an oxygen with 1 hydrogen also covalently bonded at the end. An example of an aldehyde is formaldehyde, which is what people used to use to preserve dead bodies. That's called it's a preservative, formaldehyde. Okay, so now back to the question. So we know the chemical formula for heptanol, which is a type of aldehyde. They want us to find the gram formula mass. All that means is that we have to look up the mass of the elements, carbon, hydrogen, and oxygen, and add up how many of those atoms there are, and then we will have the mass of this molecule. So now we need to go to the periodic table. So let me clear all this. Okay, so let's go to periodic table. I need to rotate this clockwise. Okay, so here we go. So the elements are carbon, hydrogen, and oxygen. So let's see. Carbon, the mass is 12. So we could just round it to a nice 12 there. The mass of oxygen is about 16. And hydrogen's mass, is 1. So carbon's mass is 12 on average. Oxygen's mass on average is 16. And hydrogen's mass on average is 1. So all we got to do is multiply. So let's see. The gram formula mass is going to be carbon. There are 7 carbon atoms times the mass of carbon is 12. And I can even do this. I'll do it step by step with you. So let's see. Got 7 times 12. Okay, so that's 84 atomic mass units. Okay, next, hydrogen. The mass of hydrogen is 1. So there's 14 hydrogens times the mass is 1. So that's just 14. And oxygen, there's only 1 oxygen, and the mass of oxygen is 16. So that's just 1 times 16. Okay, so let's add those up. What do we got? 84 plus 14 plus 16. There we go. The gram formula mass, or the molar mass, is 114 grams for every mole. There you go. Let's keep it going. This one is really easy. It's basic chemistry and physics knowledge here. Compare the mass of a proton to the mass of an electron. Okay, you should know this, but let's pretend like you totally don't remember this. So if you totally don't remember the mass of a proton or electron, we have table O. And if we fix this, okay. So reference table O, symbols used in nuclear chemistry. Don't forget, it does not only have to be used for nuclear chem, you could use it for, well, whatever you want. So check this out. So if you don't remember this, you have a beta particle, which is really an electron. Okay, so a beta particle is really an electron. And of course you have neutron and proton. All right, so you remember how these symbols are set up. The top left number is mass, the bottom left number is the charge. So if we look at a beta particle, that's really an electron, and the mass is 0, and the charge is -1. And a proton, the mass is 1, and the charge is 1. So this is easy. If we go back to the question, the mass of a proton versus the mass of an electron, a proton has more mass than an electron. That's putting it mildly. An electron is actually 1,800 and something times lighter than a proton. So protons are literally about 2,000 times more massive than an electron. So it's a big deal. So electrons, their mass is not 0, but we put it as 0 on the reference table because it's basically, the mass is really, really small for an electron. So you basically round it to 0. All right. And let's do one more. Number 57 says, in nature, 1.07% of the atoms in a carbon sample are carbon-13 atoms, which means that out of all the atoms in a sample of carbon, you're going to have a couple that are the carbon-13 isotope, meaning they have 6 protons and 7 neutrons, and that adds up to 13. And it says in the space in your answer booklet, I'm just going to do it below. It says show a numerical setup. So here we go with that. When you see show a numerical setup, that really means show your math. And they're not going to mark your answer, but they do need to see all your math. So calculate the number of carbon-13 atoms in a sample with this many atoms of carbon. Okay, this is the same thing as saying, let's see if I open up. So this is the same thing as saying, okay, out of 100 apples, 1.07% of the apples are yellow apples. How many apples are yellow? That's really easy. You're going to do 100 times 1.07%. The only thing is, remember a percent you have to change it back to its decimal form by dividing by 100, because to make a percent, you multiplied by 100. So to turn a percent back into its decimal form, you divide by 100, or you could do it easier. You move the decimal to the left 2 places. So 1.07% is really the number 0.0107. So to find out how many apples out of these 100 are yellow, if only 1.07% of the apples are yellow, we just do 100 times 0.0107. That's it. So let's find out. So 100 times 1.07, that's 1.07 apples. So you can't have 0.07 of an apple, or we could, but forget it. Anyway, basically one apple out of the 100 are going to be yellow. So all we got to do is the same thing except with carbon atoms. So basically we're just going to say, okay, you have 3.28 times 10 to the 24th carbon atoms, and out of those 1.07%, or actually maybe I shouldn't do that. Let's show them that we know how to convert 1.07% to 0.0107. There we go. That's it. So, I mean, they said just to show a numerical setup, but that's a little silly. Let's actually find out how many atoms of this carbon sample are carbon-13 atoms. Let's see. 3.28. Here, I'm doing it on a separate calculator. I'll do it here instead. 3.28 times 10 to the 24th power times 1.07%. Okay, so then there are 3.5. I'll just round it. 3.51 times 10 to the 22nd atoms. That's it. Cool. That should be good. 3.28 times 10 to the 24th times 0.0107. Yep. There you go.